Hey guys, welcome to another lecture from Introductory Statistics. Today we'll be talking about something called parameter in statistics. You must have often heard this word when it comes to statistics, parameter. What is a parameter? Now, in order to understand what parameter is, we'll try to understand the concept of parameter in association to probability distribution. For that, I'm going to take you back to an example that we worked on in the previous class. Consider whether the next person buying a computer at a certain electronic store buys a laptop or a desktop model. Now, in this, we gave X, the random variable, two values, 1 and 0. 1 if the customer purchases a desktop, and 0 if the customer purchases a laptop. And I asked you what random variable it is. Yes, it was Bernoulli random variable. And in that, I gave you the probabilities. I said that if 20% of all purchasers during that week select desktop, that means, hence we figured out with this data that the probability X takes the value 0 is 80% chance and is equal to 1 is 20% chance. So this was the probability distribution we created. Now in the same question, I could have given you another situation. I could have given you the situation that in case X is 0, probability is not 0.8, it's 0.9. It could have been the case that P0 is 0.9 and automatically P1 becomes 0.1, right? Similarly, I could have given you a situation where probability X equals to 0. P0 would have been 0.7 and P1 would have been automatically 0.3, right? So more generally speaking, the PMF of any Bernoulli random variable can be expressed in the form P1, that is probability X takes value 1, say alpha, and probability X takes 0 is 1 minus alpha, where alpha is something between 0 and 1. It's the probability, right? And just the way we had our example here, probability X equal to 1 is 0.1, 0.9, 0.2, 0.8. So you can relate it to this expression. Because the probability mass function depends on particular value of alpha, we can actually write down Px along with alpha instead of Px. So therefore, your probability mass function Px alpha is basically 1 minus alpha when x is taking x is equal to 0. It's alpha when x is equal to 1 and it's 0 for any other value. For each choice of alpha, you will have a different probability mass function. This is the concept of parameter. This alpha is a parameter which is defining your probability mass function, on which your probability mass function is totally dependent. Let's formally define parameter. Suppose Px depends on a quantity that can be assigned any one of a number of possible values, with each different value determining a different probability distribution. Such a quantity, like alpha out here, is called parameter, a very common word that is used in statistics. This is what parameter actually means. And the collection of all probability distributions for different values of the parameter is called a family of probability distributions. Let me take you through an example. Starting at a fixed time, we observe the gender of each newborn child at a certain hospital until a boy, we'll call it capital B, is born. Let P, lowercase p, be probability of boy, okay? Assume that successive births are independent, and let's define the random variable X as the number of births observed. The number of births observed, okay? Let's create the probability distribution here. This means P1 will be the probability X is taking value 1. X is taking value 1 means the number of births observed for the first boy born is just 1. We are saying that probability of having a boy is P because it's just probability of one boy. So it's P, right? Probability X equals to 2. That means number of births observed are 2. Okay. And since we are observing the births, we are observing the gender until the first boy is born. Okay. So that means this probability will be girl boy. Since these are independent, all the births are independent. So this is nothing but probability girl into probability boy. Now, probability of boy is P, that means probability of girl is 1 minus P. Similarly, P3 means probability X equal to 3. That means probability girl, boy. That means it will be probability girl into probability boy because of independence. And therefore, it will be 1 minus P square into P. And so on and so forth. So therefore, we can create a generalized formula, probability mass function, that could be Px, that means X number of births are observed. This will be equal to 1 minus P to the power X minus 1 into P, where X can take values 1, 2, 3, so on and so forth. It might not stop anywhere, okay? We don't know where to stop. It can keep on going and it's 0 otherwise. So the whole concept of parameter is, for example, in this question, the parameter that I'm giving to you is P. P is the parameter attached. So this is, you can call this Fx P, because your probability mass function depends on this P with different values of P. For example, if I take 0.5 as P, I will have a different probability mass function. With probability, say, P is equal to 0.6, it will be different. With P equals to 0.7, it will be different, and so on and so forth. You can construct different cases with different P. So this is the concept of parameter. Also, here I would like to add up the distribution that you see here is geometric distribution or the geometric random variable. Remember this kind of example. Whenever you have an experiment where you are observing until the first success occurs is geometric random variable, which is something we'll talk about later. Thank you so much. I hope this will really help you.